Okay, let's talk about greatest common factors now. So we already know that factors are the smaller numbers that make up a bigger number. For instance, in this problem, if I needed to find the factors of 18 and 24, remember I'm going to start with the number 1 and the number itself on the other end. And I'm just going to keep on going down the line. Next with 2, see who can pair up with 2 to get to 18, see who can pair up with 3 to get to 18, and then I just kind of reach the middle and I can't find any more factors. So for 18, it's 1, 2, 3, 6, 9, and 18. For 24, it's 1, 2, 3, 4, 6, 8, 12, and 24. Now, if a problem were asking us to find the greatest common factor, then we're going to put these numbers side by side. And if you notice, they've bolded the numbers that are the same. They both have 1 as a factor, 2 as a factor, 3 as a factor, and 6 as a factor. All the other factors are not the same. So 1, 2, 3, and 6 are the common factors of 18 and 24. If they're asking you to find the greatest common factor, then you're just going to look at 1, 2, 3, and 6 and see that 6 is the greatest common factor, the GCF of 18 and 24. So again, we're looking at what they have in common, 1, 2, 3, and 6, and then we're seeing which one is the greatest common factor. So between those 4 numbers, it would be 6. But first, that requires us to list the factors and then see what they have in common first. That's the greatest common factor, GCF. Now, there's another method of solving for the greatest common factor, and you could use prime factorization, which is what we talked about last time. Remember, prime factorization is breaking down a number until you can't break it down anymore. You only have prime numbers left. So what they did in this problem, which asks them to find the GCF of 225 and 750 using prime factorization, is to break it down into the prime numbers first. So 225 got broken down into 3 times 3 times 5 times 5. 750 got broken down into 2 times 3 times 5 times 5 times 5. And then again, just like before, they put the numbers side by side and they noticed, okay, there is 1, 3, there is 1, 5 they have in common, and then another 5 they have in common. So to find the greatest common factor then between these prime numbers, they would multiply all these prime numbers together to get the GCF of 75. That's only if you've prime factorized them. If you listed them like the example before, then you just need to pick the one that's the greatest and common between the two. If you use prime factorization, then you're going to see which prime numbers they have in common and how often, then multiply them together. So this method is probably best with the prime factorization if you have big numbers, so you don't have to kind of deal with listing so many factors. But the downside is then you have to kind of do a lot of math at the end anyways. So they both have their pros and cons, but know that there's 2 different methods. You could list the factors normally like before, or you could use prime factorization. All right, let's go ahead and try a problem on our own. Find the greatest common factor of 52 and 36. Pause the video and figure it out on your own first. So I'm going to list the factors of 52 and 36. Starting with 52, 1 times 52 will get me to 52. Going down the line now, I have 2. Half of 52 is 26. So 2 times 26 will get me to 52. 3 will not work. Let's try 4. 52 divided by 4. I can use my calculator. or do that in my head. 4 times 13. Let's see, does anything else work? 5 doesn't, 6 doesn't, 7 doesn't, 8, 9, 10. Yep, none of the numbers between 4 and 13 work, so I'm done. Then I have the factors of 36, 1 and 36. 1 times 36 will get there. 2, so half of 36 is 18. 2 times 18, 3 and 12. We have 4 and 9. And then we have 6 times itself, so we'll just put 6 in there one time. All right, so those are all our factors for 52 and 36. I'm going to circle our common factors. 1, 2, 4, and that's it. I almost circled a 6, but that's a 26 and a 6. So our greatest common factor is 4. Hopefully you got that. Now let's try the prime factorization method. So we're going to break 52 down into our prime factors. 52 can be broken down into 2 and 26. 2 is a prime factor. 26 can be broken down into 2 and 13. And now those are both prime factors. Okay, so again, 52 broken down into 2 times 26. 2 was done, so I circled it. It was already a prime factor. 26 can be broken down further into 2 times 13. They both are prime factors and can't be broken down anymore. Then we move on to 36. I know it can be broken down to 6 and 6. Remember, the bigger numbers you can get to, the better. They're easier. 6 can be broken down into 3 and 2, and this one can be broken down to 3 and 2 as well. 2s and 3s are both prime factors. So that's it. Those are the prime factors. Since we're using prime factorization, we're going to list the numbers that they both have in common, all of the common factors, and multiply them together. Okay, so they both have 1, 2, so I'm going to list that 2. They both have another 2. So I'm going to list another 2, and that's it. They both just have 2 2's in common. So their greatest common factor is 4. Okay, so I kind of like the prime factorization method better in this situation because I don't have to keep track of all the pairs, and I know I'm done because I just have all my prime factors. The only tricky part is I have to, at the end, multiply the ones that are repeated together. But other than that, I kind of like it. So, I don't know, use whichever method you feel is better.